Okay, hello everybody. I hope everybody's doing well. Today we are doing 7.4 Le Chatelier's principle, and I will be posting the virtual lab today as well, which will be due on Tuesday. Hopefully everybody has handed in 7.2 in partners, or if you did it alone, that's fine as well. Okay, so here we go. We're going to get started. Okay, so I have posted 2 PowerPoints, but I am going to teach using this PowerPoint because I do find it's a lot more visual. After today, you will be able to use Le Chatelier's principle to predict the shift in equilibrium for changes in pressure, temperature, concentration, and addition of a catalyst. So what is Le Chatelier's principle? So let's just recall what equilibrium is. Equilibrium occurs whenever 2 opposing reactions occur at the exact same rate. So example, SO2, when it's combined with oxygen gas, makes sulfur trioxide, and it happens at the same rate as the reverse reaction, SO3 breaking apart into SO2 to O2. So although the rate of the forward reaction equals the rate of the reverse reaction, it doesn't mean that the amounts of the products equals the amounts of the reactants, as we went over before. So Le Chatelier's principle states that if you apply a stress to a system in equilibrium, the reaction will react or shift in a direction to relieve that stress. Okay, so just like when your body is in balance and is in equilibrium, and let's say you get really bad sleep one night, you are going to react to that stress, to your balance, by sleeping in more or taking a nap later that day. So that's just an analogy. So the first stress that could happen is a change in concentration. So if you increase the concentration, it causes the system to shift in the direction that will use that substance up. A decrease in the concentration causes the system to shift in the direction that will make more of that substance. So you won't really understand what this means until we go through an example. So here we go. So here we have SO2 plus O2 makes SO3. So let's say we increase the concentration. So this arrow up sign means increase, and the square brackets means concentration. So let's say we increased SO2. So now our perfectly in balance at equilibrium has been stressed because now this has gone up. So picture literally a balance, and now this side has gone up. So what are we going to do to relieve that stress? It's going to shift this way, okay, so that the equilibrium is reestablished. So it will shift to the right to relieve that increase in concentration. Okay, so let's say we increase the SO3, the product. So now our perfectly aligned balance has gone up this way. So it's going to shift this way to the left to relieve that stress. Okay, let's say we decreased oxygen. So our perfectly in line balance or scale has now gone down on the left. So what are we going to do to make it reestablish a new equilibrium? This side is going to shift to the left, right, to reestablish that new equilibrium. Okay, so changing the concentration of a pure solid or liquid has no effect on the equilibrium. So this only works if there's gases, just like we talked about in the KEQ constant expression. Okay, so here we do have a solid. Okay, so this will have no effect on the Le Chatelier's principle. So if we increase NaCl right here, this is also a solid. So what would happen? No change. If you decrease Na, what would happen? No change. Okay, so change in temperature. So changing the temperature on an equilibrium reaction depends on whether the reaction is endothermic, where the energy is absorbed, or exothermic, where the energy is released. So we treat the energy or the heat term as a reactant or a product, okay? So here in an endothermic reaction, the energy term is going to be in the reactants part. So here we go. A plus B plus 100 kilojoules. So this is treated as if it's a reactant. So if you increase the temperature, it's as if you're increasing the concentration of the reactant, okay? So that's how I look at it. Exothermic, you're treating the heat term as a product. Okay, so here we go. So like I said, treat the heat as a reactant or product. So if we increase the temperature, we're going to put an arrow right here beside this heat term. And again, with your balance, you're increasing the product side. So which way is it going to go? To the left to relieve that stress. Okay. If we decrease the temperature, it's going to go down like this. So the left is going to move to the right to relieve that stress. Okay, so here we have 286 kilojoules plus hydrogen plus oxygen makes water. So this is an endothermic reaction. So if we increase the temperature, so this is going up, to relieve that stress, it's going to shift to the right. Okay, if you decrease the temperature, so this has gone down now, literally it's going like this, so it's going to shift to the left. Okay, so changes in pressure. So this only affects gases. If you increase the pressure, volume decreases. So you should know that inverse relationship, that as pressure increases, volume decreases. So if they say in the question, which way will the equilibrium shift if the pressure is increased, you are simply looking for the side that has less volume or less moles of gas. Okay, so here's our example. So on this side, we have only 1 mole of gas, right, of Cl2. On this side, on the product side, we have none because there's only a solid. Okay, so if we wanted to increase the pressure, the side that has the less amount, so increased pressure means decreased volume, so you're picking the side that has the least amount of volume of gas. Okay, so this has 1 mole of gas. This has 0 moles of gas, so we are going to pick the right. Okay, if you decrease the pressure, you are increasing the volume, so you're going to shift toward the side with more moles of gas or increased volume. So here, if we decrease the pressure, you're increasing the volume. So we're picking the side that has more moles of gas, which is the left side. Okay, in this example here, there are 2 moles of gas and 2 moles of gas on both sides, so they're equal. Okay, so in this case, there would be no change. Okay, so addition of a catalyst does not affect the equilibrium position. Okay, it only affects the rate of the reaction that we learned in the last unit. Okay, so whenever they say how will a catalyst affect this equilibrium, you always state no change. Okay, so let's go to the next PowerPoint that I posted, and this will be your assigned questions. You can go through it if you want. It's just a little bit more notes, but it's basically the same idea as that first PowerPoint, which is a little bit more visual. This is a good example here with nitric acid formation. Okay, so this goes through exothermic, endothermic reactions again, and changes in gas volume. So you could read through these examples again, and this is the assigned work here, page 446, number 1 and 3, and then as well, I'm posting a worksheet with the answer key on it. Okay, and then I'm also going to post the virtual lab for Le Chatelier's principle. Okay, so hopefully you understood today's lesson. Just make sure you do the practice questions and you read the assigned textbook section as well. And have a great weekend. Bye.